Tables are a really common way that data sets are provided to us. And so understanding what tables look like and how we turn them into visualizations is an important step for visualizing a lot of the data that we'll end up interacting with. So what is a table? Tabular data is essentially data that tends to be more than 3 dimensions. So we're not talking about X, Y, and Z positions in the physical space here. What we're usually dealing with is rows and columns, where columns represent different dimensions of the data. And that can be anything. It can be numeric and can be categorical. And this is really commonly how we think about data, like we would have in a database, where we have a bunch of different attributes, a bunch of different rows or entities that we know those attributes about. To visualize that, we can't just visualize it all and plot it into a 3D space. First, some of it is categorical, so that doesn't work. And even if we were to convert that, it's multidimensional, and so it doesn't fit nicely in a 3D space. That means you either need to project it down or get creative in how you explore it. And that's what we're going to look at today. A bunch of different ways for interacting with tabular data. Just to be clear, quantitative data, if we have that in a table, we are probably used to seeing things like scatter plots, where we have values on the X and Y axis, and then we plot 2 of those dimensions here. You have often more than 2 dimensions though, so scatter plots aren't going to handle everything. You also can have categorical data, where you have a certain set of categories and then numbers for each. And that may be something that you show like as a bar chart, or something a little more creative, like we can see on the right here with top Twitter users and their follower counts. You can use matrices, which we'll take a look at. If you have lots of different keys, so we want to look at a whole bunch of different attributes at once, you could do things like hierarchies, and we'll take looks at examples of all of these going forward. But the point is, in tabular data, you can have many different values, you can have many different keys, and your values can be quantitative or categorical. In the visualization pipeline, the data tables come in basically as the second step of the data process. So we get in all of our raw data, and then essentially we want to break that down, put it into tables, so we have it in a nicely organized format that we then can start turning into visual things that people can interact with. Okay, so how do we visualize tabular data? We have to deal with limited visual variables. Primarily, space is an issue. We essentially have 2 dimensions in space, but we have multidimensional data. Sometimes you do have 3D visualizations. That tends to be restricted to scientific visualizations when you actually have representations of 3D space and you want to see, say, fluids moving or how a rocket might dynamically move in space. You'll do a scientific visualization. But for information visualization, we tend to stick with 2D. 3D cognitively is really hard to deal with and understand. It takes a lot of work. But that means that we need to get creative with how we can convert this multidimensional tabular data into a 2-dimensional space. The inspiration for this is 3D computer graphics, where the 3D world is projected down into 2 dimensions. So you only see 2 dimensions on the screen, even though there's a 3D world represented there. And so we want to think about how is that done in the 3D space, and can we use that as inspiration in this multidimensional space for projecting it down to 2 dimensions. The method that we use here is called dimensional projection. That is a very fancy term, and basically what it means is that we flatten down our data, so we're essentially able to look at whatever we have in only 2 dimensions. And we tend to get creative to find different ways to represent that. But dimensional projection is the term that we use to talk about how we take our multidimensional data and put it down into something that we can visualize in 2 dimensions. This is one example of doing that with a kind of physical representation. So this looks kind of like a topographic map. And you can see we've got what would be latitudes and longitudes with the gray lines that help highlight the fact that the kind of blue and purple spaces are higher up on this, and the yellow and red spaces are lower down. But this does not have to be a representation of actually a physical topographical space. This could be something like a scatter plot on the XY axis, and then the vertical elevation would be essentially a Z axis, a 3rd dimension that's representing other quantitative data. So none of this needs to be physical space. So we could have like age on one axis, weight on another, and height on another, and you could still project that into a graph like this, which is shown two-dimensionally but has a feel of 3 dimensions. We also can use a bunch of different graphs to represent data. So these are 3 different examples of how each variable kind of gets its own graph. Let's just talk about this one with the pie charts in the top. This is a graph of national flags. And so the colors represent the colors of the national flag, and the percentages that they take up is how much those colors take up in the flag. So if we see, for example, there's a bunch of European flags here that are 1/3, 1/3, and 1/3 of 3 different colors, because the Europeans like their 3-stripe flags. So that would mean 1/3 of the color of the flag, say for Germany, is red, 1/3 is gold, and 1/3 is black. And so we can see that some of the flags are really colorful. They have lots of colors. Some only have one or just a tiny little fraction of another one. And so you get a picture here of all the flags at once with how much color and what colors are in each one. Is this an effective visualization? I think there's insights that you can get out of this, but it's useful if you're kind of trying to explore, say, what colors are most common, what percentages are most common. If you're trying to do a query, this is really bad. It's hard to figure out what country's what without a lot of other tools. Just to look to the right here, this is called the trilogy meter, and what we have, each long rectangle is a trilogy, and it's divided into 3 squares representing the different movies. You also will often see things like these stacked charts at the bottom where you have data with the same x-axis and then you're showing the y-axis in a few different ways. If we flip over here, I love how this is done on the Weather Underground website, where they actually show you a bunch of data, kind of like that. They have 3 different stacked graphs here. So this one's showing you temperature on the top. We're seeing pressure and chance of rain on the bottom, or in the middle, and then on the bottom, wind speed. We can see the y-axes over here. They all share the same x-axis, which is time. And then you could actually consider this forecast bar across the top to be kind of a 4th bar, that for an entire chunk of time, one whole day, it's giving you a little bit of extra data about that. So it's a way that we're taking a bunch of data and putting it together. And here, even if we ignore that top column, we get temperature, pressure, likelihood of rain, and wind speed in a set of stacked graphs. Okay, another example of how to do this, to take a bunch of tabular data and show it into one visual space. This is something called Chernoff faces. This is from 1973, so this is a really old technique in terms of information visualization. But it's using faces to represent several different facets of data. So let's actually look at this one, Life in Los Angeles, over on the right, because I think the images are just a little bit clearer. So we have a key down here in the lower left. The shape of the face represents affluence, basically how much money is there. So big round faces have more influence, round faces have more affluence, narrower faces have less. The unemployment rate is shown with the mouth. So if it's kind of smiley, it's low. If it's a medium rate, it's a straight line. And if there's high unemployment, you have a frowny face. Urban stresses are shown with the eyebrows, basically. So you can see eyes with just kind of low arches on the eyebrows have low urban stresses. There's straight eyebrows for medium, and then there's kind of sharply angled, angry eyebrows for high urban stresses. And then the proportion of the population that's white is divided for high, medium, and low. And so what we see here in this graph, we can easily see that most areas of Los Angeles have high white populations, except these 2 places here, where one has medium and one has low. We can see for both of those, there's high unemployment and high urban stresses and low affluence. There are plenty of places that have low affluence and a high white population. They tend to neighbor those low and medium white areas. So there's high white population, but low affluence. These mostly have a medium unemployment rate, except for this one, which has a low unemployment rate. And they tend to have medium urban stresses with these straight eyebrows across. And then as you move up here, we can see we get more round faces. The round faces tend to have lower urban stresses. There aren't any low unemployment rates around those. And so you're getting 4 different variables represented in this one icon, basically, that's then put onto a map, so showing us those 4 attributes across a geographical space. A similar technique is used over here for death penalty executions, with face shape, color, and then the mouth for average age, and then the eyes actually represent the methods used for execution. And so there's a lot of circles for lethal injection, but you can see that there's other examples that pop up in here as well. So again, we're taking 4 pieces of data and showing them in the icons, putting that onto a map, and then the map is also color-coded to indicate if the states have the death penalty or if it's being used. So that's looking at static data. Dynamic data or dynamic queries is another way that we can interact with the data a little bit more. Dynamic queries were developed by Ben Schneiderman here at the University of Maryland in the 1990s. And the idea is that data tables are something that we're used to in databases, but if you want to query a database, you have to write essentially SQL queries. You certainly did then, and that's difficult syntax, and it's really slow, and you have to, if you have a bunch of queries you want to do, you have to make a bunch of SQL queries. So he invented this idea of using sliders to represent SQL queries. So you're used to these sliders all over the place where you grab the little slider on a scale and you can move it, you can select a range, and then that changes what you're able to see. The first example of this that they have is a tool called Home Finder. It looks very dated now. I thought this was like the best thing ever when I came to the University of Maryland in 2001 and saw this, and I couldn't figure out why it wasn't commercially available. Now this kind of tool is out there all over the place. I'm not going to show you the video in my lecture. There's a link to their original YouTube video posted in the Canvas materials, or you can go to this link up here to watch it directly. But essentially what you had is this is the Washington, D.C. Each little yellow dot represents a home for sale. And then there's a set of sliders over here. So as you move the sliders, dots would appear or disappear. And not only does that allow you to make a query where you can see what homes are available in the given price range or district or bedroom range, whatever you're looking at, it also allows you to see how the changes that you make in the slider relate geographically. So what you could see, for example, as you dragged the slider for cost, you would often see a kind of cascade effect where parts of the map would slowly disappear. Here in the $500,000 range, we're not seeing anything over here in Montgomery County. If you were to slide that up, you would start seeing more homes appear up there. So it not only allows you to query easily with the sliders, it allows you to visually watch what appears and disappears dynamically to better understand the way all of your data points relate to the geography and the attributes in the data that you're looking at. So check out the video. Another application they used for this was Film Finder. Again, looks a little bit dated now with the colors and everything, but the idea is a good one. Here you had more categorical data, so you could kind of slide along an A to Z scale and pick out individual actors and directors, change the length, select different ratings, and then see how that affected what you were seeing. We had an XY axis here with year of production on the X-axis and popularity on the Y-axis, again with their own sliders. This was also present in Spotfire. This is the original version of Spotfire, and you can see that these sliders here over on the right-hand side where you can drag on the lower end and on the upper end and dynamically change what you're viewing. It's also present in the current version of Spotfire. So again, if you look over on the right, you can see that there are sliders that you can move that will again filter the data and show it to you in a bunch of different views now based on the queries that you've made by using the sliders. So that's dynamic queries. Let's also talk about spatial layout. Where do we put the data that we're looking at if it's in a tabular form? One thing that is really common and that we're going to run into a lot are scatter plot matrices or SPLOMs. So you have a 2D scatter plot for all combinations of your data. And so what we can see here is that we have a set of attributes across the top. So these are labeled. This is a car data set. So we have miles per gallon, year, cylinders, acceleration, horsepower, and weight. The same things are available down the y-axis: MPG, year, cylinders, acceleration, horsepower, and weight. Now, some of these are categorical. You can't have 1.5 cylinders. So we have whole numbers here, and that's why we get these nice lined up values here, because for cylinders, which we're seeing on the x-axis in this column, I think we have 4, 6, and 8 maybe as our options, and then 2 over here, which there aren't a lot of that we can see. What we also see is that when we have the same variable, we get a nice little diagonal showing up. So we have diagonals going across here when the variable is both on the x and the y, which makes sense. And what this allows you to do is very quickly make an assessment of how one variable relates to others. So for example, if we look at this first row for MPG, we see that there's this nice curve here between MPG and horsepower. So MPG is shown on the y-axis in the row because we're looking along the side here. So as the horsepower goes up, the horsepower is on the x-axis, the MPG goes down. We see the same thing with weight. As the weight goes up, the miles per gallon goes down. That makes sense. Now we've seen these two curves here that look really similar, so that can actually prompt us to say, well, maybe there's a relationship between horsepower and weight because they tend to have the same relationship with MPG. So we can go down from horsepower to weight, and we see that there actually is a pretty linear relationship between the two of those, which matches here. This is horsepower on the x-axis, weight on the y. This is weight on the x-axis, horsepower on the y. And so we can see those together. It's a little bit harder to see patterns when we've got kind of categories. Again, year like cylinders, we don't have half years on cars. They come out each year. But with the color coding here, we can see that there's more green dots on the upper part and more red dots on the lower part. So these scatter plot matrices allow us to really quickly see where are there patterns that we can then dive in and investigate more deeply. Here's another scatter plot matrix. And so we can see, for example, looking here, a lot of really clear linear relationships going on in this data, and not just on the diagonal. So those always make interesting things to look at and see what those variables are and maybe where they may have relationships with others. Parallel coordinates are another technique for doing spatial layout of tabular data. And essentially there what we're doing is mapping each data dimension to graphical dimensions. They each get their own axis. And we only have two, an x and a y, but what we do is draw a bunch of different y axes and line those up and connect points for each row across those. So it sounds a little bit weird. We're just going to take a look at it and see what it means. So here's an example. So we have that same car data set. It's a little grayed out here, but what you can see on the bottom is we have miles per gallon, cylinders, horsepower, weight, and year. We have a vertical line for each of those attributes. And then for an individual car, we will find the point where its mile per gallon is on the y-axis here, and we'll connect that to the point where its cylinders are on the next y-axis, and connect that to the point where its horsepower is on the next y-axis. And so you have a line zigzagging through the data for each car. How is that helpful? What it allows us to do is see, for example, for cars with 8 cylinders, which is this point up here, every car with 8 cylinders connects to that point. And we can look at where does that data go. So if we follow that out to the right onto the horsepower axis, we can see that there's a pretty even spread of horsepower among the 8-cylinder cars. If we were to follow it to the right to the miles per gallon, we can see that all of these go to the lower half of miles per gallon. So if you have 8 cylinders, you're not getting great MPG. There's nothing good up there. If we look at cylinders, for example, here, which I think would be a 4-cylinder engine, you can see that those going back to the MPG axis, none of those lines go to like the bottom quarter, bottom third. They all spread from kind of the middle low to the high end. So that gives us a really clear relationship between these data points. The same thing here, just one more example. If we go from cylinders over to horsepower, we can see that these 4-cylinder engines are all in the lower half of horsepower. Even the next line up here, I think this one would probably be 6. The 6-cylinder engines are in the lower half of the horsepower. The 8-cylinder engines take up basically all of the upper half. They go down further. They also have some lower horsepower. But if you're in the upper half of horsepower, you're coming from the 8-cylinder place. So they're a little confusing to just look at. But once you know what you're looking for, which is how those lines flow from one axis to the next, you can get some interesting insights. And you can also reorder the axes. So for example, here we can only look at the relationship between cylinders and the axes on the left and right, MPG and horsepower. If we were curious about the relationship between cylinders and weight, we could drag the weight axis over here in place of where horsepower is to see that relationship more clearly. Here's one more example. What we've done here is click on all of the 8-cylinder engines. And so we're seeing what we saw before with the link to horsepower, but then we can also kind of see all those lines are blue, so they all tend to be up here on the weight end. The 8-cylinder cars tend to be heavier. And if we drop down to what I believe is acceleration here, they're all in the lower half of acceleration. Okay, and here's one tool that you can use to try this out. This is XMDV tool. It does this kind of visualization for you, so you can load in some data. It's freely available, and parallel coordinates are one of the things that's available in there, so you can go ahead and try it out. And then finally, Tableau, which we're going to be looking at extensively, is a tool that's available. You can get a free trial version of this as a student from the website, and I've provided you for a link, provided a link for that in the course materials. It does a lot of the stuff that we've been talking about today. It's a commercial product. It has all kinds of fancy ways of doing interesting linked visualizations, and it's really designed to take tabular data and show it in interesting ways. So, just as an overview, tabular data is essentially data where your rows would represent an entity and you have lots of different columns. Those columns are attributes of your entities. We can refer to them as dimensions here. And when you want to visualize tabular data, you need to figure out how do you take that multidimensional data, all those different attributes, and visualize them essentially in a 2-dimensional space. It may be that you're just selecting parts of those, but often you want to come up with creative ways of representing a bunch of different of those attributes with different visual indicators and showing them to people in a way that they can see as much as possible at once. Also use dynamic features like dynamic querying to see relationships. Animation is something that we're starting to see more of, and also to see multiple views at once. So there's a quick overview on looking at tabular data, and I recommend taking a look at Tableau as a next example of a tool that is going to allow us to interact with and better understand that.